have we stopped yesterday? Yes, can anyone tell where we have stopped yesterday?
So that associative law we stopped yesterday.
Oh, good. Thank you. So today we'll start with distributive law. Okay. This is as one more law, that is, sorry, distributive law. Distributive law. Puja or until and unless I ask question, please mute yourself. Okay, please mute yourself, because whatever you are speaking, you may not get it audible. You'll feel that you are in mute. Okay, better try to concentrate on mute button also, because it disturbs whole class. Okay, it is for everyone. Okay, it is for everyone. Okay, keep an eye on your mute button whenever you speak. Okay, right. So in distributive law, I think it is law number 18. Law 18. So A into B plus C. Can I write this as AB plus AC? Can I write?
Yes, sir.
I can write. Right. Law number 19. A plus B dot C is equal to A plus B into A plus C. Can I write? We'll prove this. I know many of you will have doubt on this. We'll prove this. Let me prove this. Okay. So take RHS for this 19th law. I'm proving that. Okay. Because anyhow this everyone knows. Okay. This everyone understands how we got this. But this I can understand. Many of you have not got it. But we'll prove that. Okay. So what is LHS? LHS is equal to A plus B dot C. Correct? This is LHS. Now you see in Boolean algebra, okay, always when you are solving this type of, or when you are solving this type of equations, Boolean equations, we say this as Boolean equation. Okay, this one is one Boolean equation. This is one Boolean equation. Okay, these are all called Boolean equations. Okay, so whenever we are solving such Boolean equations, or sometimes we say it as reduce the Boolean equation. Sometimes they'll ask the question. Okay, reduce the following Boolean equations. Okay, so whenever you are dealing with this type of Boolean equations, okay, always see that. Say for example, here A, okay, is alone. Correct? A variable is alone. B is associated with C. Correct? B is associated with C, A is alone. So try to bring this B and C to A. So let me tell one more thing. In the beginning, many of you will have a bit trouble in understanding these concepts. Okay, but as we move on, you will be having a clear picture how to solve this type of Boolean equations. Okay, in the beginning, nothing to worry. As we move on for many examples, you'll understand one by one. Okay, so at a time, many of you don't understand all the concepts. Okay, okay. Now you see, can I write this A as A dot 1, because A dot 1 is nothing but A? Can I write?
Yes, sir.
Right. Plus BC as it is. Now, can I write this one as, because I want to bring this one of these two parameters to a association. So I'll write this as 1 plus b, because 1 plus b is nothing but 1, correct?
Yes, sir.
Correct? Because 1 plus b is nothing but b itself, correct? Because this 1 plus this 1, can I write as 1 plus b, because 1 plus b is nothing but 1? Understood? Boolean laws which we have done yesterday. 1 plus anything is 1, correct? Respond please, so that I'll keep moving.
Yes, sir. Understanding.
Right. So now you multiply inside, what you get? You get something like a plus ab plus bc, correct? Now you have this equation, correct? Now
Yes, sir.
a is alone. So which one I have to associate now? I have associated B. Now C is left over. Now you associate C with A, that is A into 1 plus C plus AB plus BC. Can I write? Because 1 plus C is nothing but 1. Correct?
Yes, sir.
Right.
Yes,
So
sir.
now I'll again expand it. It will be A plus AC plus AB plus BC, correct? Can I write this A as A A plus AC plus AB plus BC? Can I write? Yes, because A dot A is nothing but A. Can I write?
Yes, sir.
Right. Now you take common factors. That is, you take A out of this as common. What will be? A plus C, correct? Plus you take what you can take B as common. What do you get? A plus C, correct?
Yes, sir.
So what is this equal to? A plus B, A plus B into A plus C, correct? Which is equal to RHS. Got it?
Yes, sir.
Right. Don't
Yes,
worry.
sir.
As of now, don't worry. I know many of you have big question marks, but still let us keep on moving. You understand one or two steps in every problem. That's quite enough. Okay? Right. So this is how we'll prove it. Okay? What we have to do is, the basic funda in this is, see, A is alone, B is associated with C. Okay. So what we have to do is, in any case of Boolean equations, okay, you try to associate with the single variable. Okay. So with A you try to associate B first, and with A you try to associate C first next. Okay. That's what we have done here. Okay. Right. Next we will see next law. Law 20. A plus A bar dot B is equal to A plus B. A plus A bar B is equal to A plus B. We'll prove this, okay? Because you are new to this, probably you feel, many of you will feel that it is, how do we got this, right? So we'll prove that. So what is LHS? A plus A bar dot B. This is LHS, correct? So can I write this as something, because A you leave it, because A and A bar no need to associate, okay? Only B we have to associate with this single variable. So A into 1 plus B plus A bar B. Yes, can I write?
Yes, sir.
Right. Now you multiply inside. So A plus AB plus A bar B. Can I write? Is it correct?
Yes, sir.
Right. Now A plus, you take B as common in this, A plus A bar, correct?
Yes,
Yes,
sir.
sir.
So A plus A bar what?
1, sir.
So into 1, which is nothing but A plus B. Understood? Right. So I'll just, if you have a paper and pen, in the side itself you write down some more important factors, something like, um, okay, when time comes I'll tell now. Okay, not required now. When time comes I'll tell this. Okay, because if I tell you'll get confused. Right. So law 21. X plus xz is equal to x. Is it correct? Immediately you can tell it will be right, correct? Because take x common, what do you get? 1 plus z. 1 plus z is nothing but x into 1, correct? Which is nothing but x. Correct? Any doubt?
Yes, sir. No, sir.
Right.
No.
Next. Yes. We'll prove. Take LHS. X into x plus y. So multiply inside. We get xx plus xy. And what is xx? Is nothing but x. Correct? Plus what is xy? You write as it is. Now you take x as common. 1 plus y, which is nothing but x. Correct?
Yes, sir.
Right. Any doubt? Any doubt till here?
No, sir.
No, sir.
Right. Law number 23. Xy plus yz plus y bar z is equal to xy plus z. Okay. Right. So how we can solve this? See, take RHS. What is RHS? Even if you go wrong, try to do nothing wrong. I'll correct you people. Okay. Upon trying only, you will get familiar to this kind of Boolean equations. Okay. So xy plus in this two, if I take z as common, what do I write? Y plus y bar. Correct?
Yes, sir.
Xy plus z, because y plus y bar is 1, which is equal to RHS. So probably you will be thinking, some of you might be thinking, sir, why you have not taken, how you have taken z from this two? Why not you have taken y from this two? Right? So first, see, this is what Boolean algebra is. First, we have to look whole equation where I have to give priority. Okay, where I have to give priority for taking common. Okay, so if you give y here, it will be y into, say for example, say RHS, just for your understanding this. Okay, RHS. Oh my God, what is this? Right. So RHS xy plus yz plus y bar z. Say if I take y from this, because after seeing, many of you will be thinking, anyhow from this two also I can take y as common. Y Sarah has taken from this two. Yes. See, in Boolean equations, first we have to see full equation first, not just two terms. Okay, in the equation, or one term or three terms in the equation. How many terms are there? All the terms you have to put one I, and then decide which one, if I take common, I can reduce the equation. I can reduce the equation according to my requirement. Okay, that we have to analyze first. Say for example, in this case, if I take just y as common, so what the answer will be? X plus z plus y bar z. Correct? So further I can't reduce this equation further. Correct? So the other way is, so this is what, if you practice this type of equations, upon practice only you can judge which one I have to take common first. Okay, which one I have to give priority first for the requirement to achieve. Okay, so like that you have to move in. Okay, all right. So probably in the beginning, even I too felt a bit difficult. Later on, upon solving many problems on this, you'll get familiar. Okay, right. 23. Next is, so this completes the laws of Boolean algebra, and now we'll move on to theorems. Few theorems which are very important. Okay, which are very important. Right, De Morgan's theorem. Okay, there are two De Morgan theorems. Okay, there are two De Morgan's theorems. First one is x plus y whole bar is equal to x bar dot y bar. Okay, the second one is x dot y whole bar is equal to x bar plus y bar. Right. What I have done in these two, please understand carefully. In these two theorems, what De Morgan is a scientist who has found out this formula. Okay, theorems. What they have done here is, if you observe properly, they have changed. Okay, changed plus symbols to dot and dot symbols to plus. Correct? This is one change that they have done. Okay, and this is one change, and one more change which they have done is the whole complement. The whole complement is replaced by individual complements. Isn't it? See, observe properly whether these two statements are correct. Right? Observe
Yes,
properly whether these two statements are correct with respect to law theorem. So first one is a plus y whole x plus y whole bar is equal to, what is the two statements? Plus symbol is replaced by dot. Correct? So if you observe here, this plus is replaced by dot, and the whole complement is replaced by individual complements. Next, second law. If you see here, the dot is replaced by plus, and the whole complement again here is replaced by individual complements. Understood? These are the two laws of De Morgan's. Okay, so we have to do proof for this also. Okay, how do we prove this De Morgan's theorems? Okay, that is very important. So always whenever they ask state and prove De Morgan's theorems, you have to write these two and you have to state this two sentence. And how to prove this? It is very simple. Have you heard of something called truth table? Truth table is a
Yes, sir.
tool that is used to represent all Boolean equations and show its outputs. Okay, and show its outputs. I'll just teach you how to do that. Okay, now you see, you write down how many variables are there first. So you have how many variables are there in this? There are only two variables, correct? X and Y are the only two variables, correct? Am I right? X and Y, only two variables are there. Is there anything, something like Z or A, B, something like that? No. We have only two variables, X and Y. Write down that first, X, Y, okay? After this, you start writing And one more thing, yes, I'll tell you. X, y, and what is the first component here? X plus y. X plus y. And what do we need? We need x plus y bar, x plus y bar. Okay. Then we need x bar, and we need y bar, and we need x bar into y bar. Okay. What all the possibilities are there? All the possibilities I've written here. Say for example, I'll make these possibilities as each separate columns. Okay.
Sir,
Yes.
sir, x dot y the whole bar, that one, sir.
This one, the second one.
Yes, sir.
No, we'll prove first, and then we'll move on to second. First, we'll prove this A, then we'll move to B.
Okay, sir.
Understood? Separately we have to do. If I start doing all at once, many students it will go beyond their head. Again, you'll say we have not understood anything. Better we'll go stepwise, nothing wrong. That's what in the beginning only I've told. This module I'll take more time. This module will take more time compared to any other modules. Right. So we are proving for, I'll write here which we are proving. X plus y whole bar is equal to x bar dot y bar. This is what we are proving. What we need to prove, LHS is equal to RHS. Okay. How to prove? With this truth table. So what all the possibilities are there? You just write it down. Say for example, there are two variables. First I have to write two variables, x and y, and we have x plus y first. So I have written x plus y, and next I have x plus y whole bar. So I have written x plus y whole bar. Next I need to have x bar and y bar. I have written x bar and y bar, and then product of this, that is x bar dot y bar. So if there are two variables, I can have how many combinations? See, this is very important. This is what I wanted to tell. How do you decide number of combinations? So it is something like 2 power n.
N.
Yes, 2 power n. Here n represents variables, number of variables. Okay, number of variables. N represents number of variables. Here we have only two variables, correct? We have only two variables, x and y. So 2 power 2. How many combinations will get? 4. Okay, we'll get 4 combinations. Which are those combinations? So 0, 0, 0, 1, 1, 0, and 1, 1. Beyond this, we won't get further combination. Is it possible? Check it out.
No, sir.
So only this many combinations only, all possible combinations only will get. Okay, you won't get further any type of combination. Now you start filling the table. 0 x plus y means 0 plus 0. What will be the answer?
0, sir.
Yes.
0,
0 plus 1.
1,
1,
1 plus 0.
1,
1 plus 1.
1.
1.
Very good. Right. Now what is this? X plus y complement, correct? Complement means what? Negation of this
Y.
x plus y, correct? Means
sir.
what? If you have 0, you'll be having 1 here. If you have 1 here, you'll be having 0 here, correct?
1,000,000.
Yes. So for 0, what I have to write here?
1.
For 1,
0, 0, 0.
0.
for 1 again 0. Again for 1 it is 0. Understood?
Yes, sir.
Right. Now you see here x bar. Can you see here? Here we have x. So what I have to write for x bar
1.
here? 1. Next.
1.
Next.
0, 0.
0, 0. Similarly for y, you have y here.
1, 0, 1, 0.
You have for 0 you have 1, for 1 you have 0, and for 0 we have 1, and for 1 we have 0. Correct? We need to write 0. Correct?
Yes,
Yes.
sir.
Now, what is the last column? X bar dot y bar. Correct? You have x bar here and you have y bar here. So product of this. Correct? So 1 into 1 is
1.
1. 1 into 0.
0.
0 into 1.
0.
0 into 0.
0.
Right. Now, what is this? X plus y whole bar. Where is x plus y whole bar? This column, correct? This is the column. X plus y whole bar, correct?
Yes, sir.
So, which is x bar dot y bar column? This one, correct? Yes?
Yes, sir. Fourth one.
Yes. Now these two are equal.
Yes, sir.
You got 1 0 0 0 and 1 0 0 0, correct? That means column number 4 and column number 7, correct, are same. That's why first law is proved. Understood?
Yes, sir.
Right. So this is how you have to prove De Morgan's theorem. Okay? If they ask. If they ask for 2 variable. If they ask for 3 variable, we'll see that later. First we'll see 2 variable. So we'll see the second, how to prove the second law. What is second law? X dot y whole bar is equal to x bar plus y bar. Correct? Correct? Yes.
Yes, sir.
Right. Sandeep Yadav. Right. So how to prove this? Again, you write it down all the possible in the truth table. So we have 2 variables x and y. So we have 2 variables x and y, and we need to first find x dot y, that is x and y, and then x y bar. So this is done. Next, coming to right RHS, we need to have x bar and y bar separately, and then combination of this x bar plus y bar separately, isn't it?
Sir,
Yes.
sir, we will not take x plus y also.
Why we need, we don't need, no? Check it out
Yes.
whether we need that anywhere.
Needed.
Yes. X plus y, for this case, is it required?
No, sir.
Because see, if x, you are telling like x plus y, correct? So x plus y we need independently. Independent, I mean individual complement. If it is whole complement, then we will need x plus y. Understood?
Yes, sir. Yes,
If
sir.
it is whole complement, then you need x plus y. If it is individual complement, then not required, because we got here x separately we got, and x bar separately we got, and y bar separately we got. Okay.
Yes, sir. Okay, sir.
So there are two variables. How many combinations will get?
4.
Right. So there are two variables. So we'll get 4 combinations. Which are those? 0, 0. Please tell me. 0, 1,
1 0
1, 0, and
1
1, 1.
1.
Good. So these are the 4 combinations that we'll get. Right. So now x dot y means 0 into 0. This is x column and this is y column. So 0 into 0. What will be the answer?
0
0. 0 into 1.
0
1 into 0.
0
1 into 1.
1.
Right. So this is xy whole bar. Correct? Means complement of this. Complement of this. So what will be the column filling?
1 triple 0.
1,
Sorry.
1, 1,
Uh-huh.
0. Correct?
Yes, sir.
Right. Now x bar. So complement of this x. Correct? So it will be 1,
Double 1 double 0.
double 0. And what about this? Y complement.
1
So
0
it is
1 0.
1, 0, 1, 0. Correct?
Yes,
Now
sir.
x bar plus y bar means this plus this plus this column plus this column. So it will be 1 plus 1
1 1
is
1
1, 1 plus 0 is 1,
1
0 plus 1 is 1, and 0 plus 0 is
0.
0. Yes. Now what is LHS? X dot y whole bar. Where is x dot y whole bar? This column. Correct?
Yes, sir.
Yes, sir.
So where is x bar plus y bar? This column.
Last column.
So both are equal.
Yes, sir.
So this is proved. LHS is equal to RHS. Hence, De Morgan's second statement is also proved. Right? So this is for 2 variables. If they ask for 3 variables,
We'll get 8 combinations, sir.
very good. You will get 8 combinations. Okay. So because there are 3 variables, so obviously you'll get 8 combinations. So just I'll write the combinations. You try to fill it for tomorrow. Okay, for the next class. If not, we'll solve it. Okay, so I'll just write the theorem here, statements here for De Morgan's first statement for 3 variable will be, I'll write the statement a plus b plus c whole bar is equal to, can you guide me? A, I told you, replace all plus with dots, correct? Dot
A bar
sir.
dot B
dot
bar dot C bar.
C, and whole complement with individual complements. So bar, bar, bar. Understood?
Yes, sir.
Right. What is second statement? A dot B whole bar. So how do dot
Sir,
C?
A dot C bar.
Yes. How do I put this?
A bar plus B bar plus C bar.
First go with the statement. So replace all dots with plus, that is A plus B plus C, and then whole complement with individual complement. Understood?
Yes, sir.
Right. So now you try to fill this in truth table. Okay. So there are three variables. So obviously you will have, I think you have second hour free, right?
Yes, sir.
Shall I continue for another 15 minutes with your permission?
As you wish, sir.
Yes. Because this continuity should be there. This three variable I'll complete and I'll leave it out. Right. So this will be, if I want to prove the first one, three variable, a plus b plus c whole bar is equal to a bar dot b bar dot c bar. So how many variables are there? There are three variables. Start writing that a, b, c. Okay. Next, a plus b plus c whole bar, not whole bar. It is next. I need to write a plus b plus c whole bar. This completes LHS. Next, moving on to RHS, it is a bar, b bar separately, and c bar. Next, I need to write what? A dot b dot c separately. So this completes the truth table. Sometimes my lines will cross. Please don't. Okay. Now, if it is a three variable, how many combinations will get? 2 power n, which is equal to 2 power 3. You will get 8 combinations. Okay. So, how do I write that combinations? It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Correct? Yes.
Yes,
These
sir.
are the 8 combinations that you will get. So, what is first step? First, that is a plus b plus c. What do you fill this? Okay. 0 plus 0 plus 0. 0. 0 plus 0 plus 1.
1.
1, 0 plus 1 plus 0.
1.
See, it is very simple in Boolean algebra. If you find 1, and if there is a plus, you blindly fill it as 1. Okay. So we have 1 here, so fill it as 1. You have 1 here, you fill it as 1. You have 1 here, you fill it as 1. You have 1 here, fill it as 1, and you have 1 here, fill it as 1. Got it?
Yes, sir.
Right. So this column. So negation of this, correct? Negation of this. Negation of this column. So what will be negation of this column? It will be 1,
1.
0,
0, 0, 0.
0, 0, 0, 0, 0, and 0. Correct? So we'll see this. Right. A bar.
1.
So 4 ones, 4 zeros. Correct?
Yes. Yes, sir.
So
Yes,
this
sir.
is 2 zeros, 2 ones. 2 zeros, 2 ones. This is alternate. 0, 1, 0, 1, 0, 1, 0, 1. Correct? So now AND operation of this. So if you find even a single 0, the output will be 0 for AND operation. Correct? AND means what? Multiplication. Dot. So 1 into 0 into 0.
Sir,
Hmm.
Sir, in
sir,
B complement, B
Sir, in
formula,
B and C, it should be 1, 1.
B 1 1.
Sir,
Yeah.
in B it is
Yeah, yeah, got it,
1
got it,
1
got
0
it.
0 1
Got
1 0 0.
Got it. Thank you. Thank you for correcting.
Sir, in C also.
Yes. Sometimes knowingly also we do mistakes. See, this is what happens in exams also. You'll be knowing the answer, but our fate, it 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 makes us to do wrong. Right. If someone is there to correct there, it will be good to you also. Right. So what should I write here?
1 1
1 1 double
0
0
0
1 1
0
double
0.
0. Correct?
Yes,
Right.
sir.
Similarly here, it is 1 0
1 0
1
alternate.
0 1 0.
1 0 1 0. Correct?
Yes, sir.
Right. Now you do AND operation of this. So what will be AND operation of this? What will the output?
1 0
1
0
0. All are 0. Correct? Because if you find any 0, you put 0. Okay?
Yes, sir.
Right. 0 and 0. Correct? So if you see column number this and this, both are same.
Yes, sir.
So that's how the three variable De Morgan's theorems is proved. Okay, like this we can prove any number of variable theorem also. De Morgan's theorem. Okay, so this is just for your reference. Similarly, you try to prove B1. Okay, you try to prove this. Okay, as a homework. Will you prove as a homework?
Yes, sir.
Yes, sir.
Right. So with this, I'll wind up the class for today. Okay. So if you have any doubt, you stay back, or else you can leave the session.
Thank you, sir.
Okay. Take care.
Thank you, sir.
Thank you.
Take care. Take care.